Irrational numbers. The numbers which are not rational. The opposite of rational is irrational. So any number which is not a rational number is an irrational number. So any number which cannot be expressed in the form p by q, with p and q being integers and q not equal to 0, is an irrational number. I think you all get it now what an irrational number is. Irrational numbers is denoted by all real numbers except q is how we denote the set of irrational numbers, and it is anything which is expressed in the form p by q such that q not equal to 0 minus p by q such that p, q are integers and q not equal to 0 is how we understand the irrational numbers. Let's try to see more better examples to understand what an irrational number is. Before we try to identify the irrational number, the most easiest concept is identify for the given number to be a rational or not a rational number. If the number is a rational number, it is not irrational. If the number is not a rational number, then it must be an irrational number, is how we understand. Let's start with an example problem. Is this an irrational number? Is the question out here. So root 5 over 9, let's test for this being a rational or an irrational number. For example, root 5 over 9 can be differentiated with the numerator being p and the denominator being q. Now clearly my p is root 5 and my q is 9. So let me put this to the two tests of the rational numbers. So with the test number 1, I clearly identify that q equal to 9 belongs to z, but p equal to root 5 cannot be an integer. Therefore, my p equal to root 5 does not belong to z. Therefore, this number root 5 over 9 fails the first test for a rational number. And therefore, root 5 over 9 does not belong to q. It is not a rational number. So this is not a rational number, so it is an irrational number. Therefore, root 5 9 over 9 is an irrational number denoted by all real numbers except q, r minus q, is how we justify an irrational number through the concept of q. Here being this is not a rational number, so obviously it must be an irrational number. Now let's try to take more examples to understand the irrational number more better. So let's take an example problem here which says with the question, is root 5 an irrational number? Or I take root 9 because I just want to have an example which is not an irrational number. So my question here is root 9 an irrational number? So here with this example, I clearly try to simplify this to a more simplified form where root 9 can be expressed as 3, which in turn can be expressed in the form p by q because I need to put through test number 1 and test number 2. So this can be expressed as 3 over 1 where my numerator is p and my denominator is q. Therefore, I have my p which is 3 and I have my q which is 1. And clearly these two pass through the test number 1 which belongs to z. P and q belong to z and it passes through test number 1. And test number 2, because q equal to 1 can never be equal to 0, therefore this passes through both the tests of the rational number. Therefore, I clearly understand root 9 is a rational number because root 9 indirectly expressed as 3 passes through the two tests. It is a rational number, and therefore root 9 cannot be an irrational number. A number which is rational can never be rational, and a number which is irrational can never be rational, and therefore root 9 being a rational number cannot be an irrational number. Is how we justify the irrationality of a number based on its rationality. To be continued with the examples, this session deals with the exceptional irrational numbers which we identify in the branch of mathematics. So let's see what these exceptional irrational numbers are out here. For example, I take the most popular mathematical symbol, which is pi. We all know that pi has a specific value, that is 3.14, and it continues forever without ending. Now this approximately we take as 22 by 7. So pi is approximately 22 over 7, but let's see if this is a rational or an irrational number. When I go with pi being 22 by 7, I clearly see that its p is 22 and its q is 7, so that my p is 22 in the numerator and my q is 7 in the denominator, and both belong to z. Therefore, this number pi, which is 22 over 7, passes through test number 1. And similarly, my denominator, which is q, is not equal to 0, is the test number 2, which the number 22 over 7 passes out in rationality. But when you see this clearly, because of the two tests, 22 by 7 is a rational number. Therefore, I need to assume that pi is a rational number. But this is an exceptional irrational number. Though it passes through the test of 22 over 7 being a q, cannot make pi as an irrational number. Cannot make it as a rational number, because pi is a mysterious number which has its value unending. Because we cannot predict, we only take the approximation of pi to 22 over 7, but not exactly equal to 22 over 7, and therefore this is not exactly a rational number. It is an exceptional irrational number. But pi is an exceptional irrational number. R minus q is how we identify the specific numbers in mathematics which are not accepted in irrational numbers. So it's an exceptional irrational number, pi. There's one more example which we can take, which is E. E is approximately 2.71, which is also an exceptional irrational number. So in the branch of mathematics, E and pi are exceptional irrational numbers, is how we identify in the branch of mathematics. Let's take one more example of an irrational number, which is very essential to understand the set of irrational numbers as compared to the rational numbers in the branch of mathematics. Non-terminating decimals. Let's justify for this to be a rational or an irrational number. What is a non-terminating decimal? A decimal which never stops, but it goes on repeating and repeating, is how we understand a non-terminating or a non-stopping decimal. For example, if I take a decimal in the form this seems to be never ending. As I form a sequence, this repeats never ending on and on till infinity. So such a decimal in the branch of mathematics is called a non-terminating or a non-stopping, never stopping decimal out here. So let's see if this can be a rational or an irrational number. To start with, the rational number, with the two tests as we have already discussed in the session. Now, for the test, this should be expressed in the form P by Q, but because it never ends out on the right, this cannot be expressed in the form P by Q. X cannot be expressed in P by Q form as the decimals never end. As the decimal part never ends, and therefore this, because it cannot be expressed in P by Q form, therefore X cannot be a rational number. In order that it should be a rational number, the first essential thing is that it should be expressed in the form P by Q, with test 1 and test 2 being followed with that. But because it cannot be expressed in P by Q form, X cannot be a rational number. Therefore, any terminating decimal can never be a rational number. A terminating decimal is always an irrational number, is how we identify the property out here. So the outcome is that the terminating decimal belongs to R minus Q, is how I understand the property of the terminating decimal being an irrational number always, can never be a rational number.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.